Welcome to Scale Up University. Welcome to the course on building applications with AI agents. So, this is the lecture 8 of module 1. And in this lecture, we will be discussing managing expectations from AI agents. So, let us first look at the lecture overview, like what exactly we will be looking at in this lecture. So, if we talk about AI wave and the failure cycle, so AI is something which we have been hearing from decades. Earlier, AI hype was very much it was there, but we also saw AI winter, wherein no development at all. And the main reason for that was the expectation gap. Like we had AI hype, but we also saw something called as AI winter. So we were not able to fulfill the hype or make it a reality. So it was a failure, missed expectations. And it was not a tech failure, but it was misaligned expectations. So this is something very important. So the learning for us is every major AI wave has failed at least once because expectations were misaligned. It's not because of any tech failure, but because expectations were misaligned. And this we have to keep in mind. Like expectation is very important. Like we cannot over expect. So managing expectations is what we will be discussing in this lecture, and it is very important for you because if you will be designing or building apps with AI agents, this managing expectations from AI agents will be very important. So the idea is that we already know that AI agents, they are very powerful. They have got huge potential. They are powerful, no doubt in that. AI agents, they can scale, and they have speed also. We can achieve state of the art automation, and we can accomplish complex tasks. So huge potential AI agents have, that we have realized also. If you have come across the previous lectures, we are convinced that AI agents are very powerful, but we also have to keep in mind that AI agents, they cannot be 100% accurate. Even they can fail. So they are fallible, they are contextual, and they're probabilistic. And since they are probabilistic, some sort of uncertainty is associated with them. They can also make mistakes. They can also hallucinate. So AI agents, there can be errors and hallucinations. There can be bias and context dependence and uncertainty, non-deterministic. AI agents are uncertain, they're non-deterministic in nature. And because of that, we cannot blindly depend on AI agents. And these are some shortcomings of AI agents. So AI agents, despite being so powerful, they have some shortcomings that they are fallible, like they can fail, errors and hallucinations. They depend on context. So bias might give you some ambiguous results or wrong answers. And they are highly non-deterministic, probabilistic in nature. So that is what this lecture will be about, wherein we will be discussing what should we realistically expect from AI agents and what should we not. And that is what this lecture is about, managing expectations from AI agents. So this answer we will, like you will get by the end of this lecture, you will be able to answer what should we realistically expect from AI agents and what should we not. If we look at the topics we will be covering in this lecture, so we'll discuss agents are powerful, not magical. Like they have some limitations with them. Dependence on model quality. So agents, they depend on model quality, their performance. Agents performance, it depends on data quality. Handling unexpected scenarios. The need for human oversight. Continuous monitoring requirements. Ethical and operational risk. Avoiding over automation, aligning stakeholder expectations, common expectation traps, designing for trust, not just compatibility. So all these topics we will be discussing in this lecture itself one by one. So this is the module 1, Introduction to Agents, lecture 8, Managing Expectations from AI Agents. And we are starting with the first topic of this lecture, that is agents are powerful, not magical. So if we talk about AI agents, they have got some limitations, like they do not understand like humans. Although AI agents are intelligent, they can act, but they are not as smart as humans. They cannot, they do not understand like humans. They do not possess intent or consciousness, and they do not guarantee correctness. And since they do not guarantee correctness, we cannot blindly trust on them. These are like some limitations of AI agents which we are discussing. So if we talk about AI agents, how they learn or how they operate, so they operate by something called as pattern recognition, probabilistic reasoning, and heuristic decision making. So now it's very much clear to us that AI agents, definitely they are intelligent, they can solve the problem on their own, but they have limitations. They do not understand like humans, they do not possess intent or consciousness, they do not guarantee correctness, because they operate via some different principles like pattern recognition, probabilistic reasoning, heuristic decision making, and hence scope of error is there. They can make mistakes. And since they can make mistakes, we have to be very careful. So the key insight to take away is agents, they simulate competence. Like agents can play the role of different humans. Like agent can play the role of a project manager, product manager, or a developer, or a strategic advisor. AI agents can play the role. So AI agents can simulate competence but not certainty. Like AI agents, they cannot assure that they will be 100% correct. They can make mistakes. So uncertainty will always be associated. And since they can make mistakes, they can hallucinate, we should not treat agents as magical. Because if you treat agents as magical, treating agents as magical leads to overtrust, poor safeguards, and systemic failures. So now it's very clear to us that agents are powerful, but they are not magical. They have got limitations with them, and hence we should not overtrust agents, uh, and we should be very careful. So that is the managing expectations from AI agents. Dependence on model quality. So now a very important thing, an agent is only as good as the model it relies on. So the performance of the agent depends on the quality of the model. An agent is only as good as the model, as the models it relies on. If models have got some limitations, then that will directly affect the performance of the agents. So what are the, so we are so imperfect model if I talk about, or model limitations if I talk about, so what are the limitations of the model? So we know that every AI model, even the large language model, we train it with huge data. Now, if there are biases in the data itself, so biases from the training data, the model will learn and model will hallucinate. Hallucinations, like some edge case, some scenario which the model has never seen before, which the model has never learned. We also call it edge cases. In that scenario, the model will get totally confused because it does not know the answer, it does not know what it is, so it will start hallucinating. So models, like they can carry biases from the training data, they can hallucinate, they can make reasoning errors, and they are very sensitive to context and prompt phrasing. This is very important. Sensitive to prompt phrasing is very important, because if you make mistakes in asking questions or telling your intent, that the prompt, then models, th- they will not work as desired. So sensitivity to prompt phrasing is also a very important point. So now it's very clear that models can make mistake. So if the underlying model if it misinterprets intent, produces incorrect reasoning. So because of the limitations of the model, like models can carry biases from training data, models can hallucinate, model can like show reasoning errors. Because of this, models can misinterpret intent, it can produce incorrect reasoning, and it can lack domain knowledge. And if that happens, then definitely the agent's decisions will suffer. Agent's decision will suffer. So a very important point, a key insight to take away from this slide: agents amplify model strengths. If model is very good, agents decisions will be very good. And in also, agents, they amplify model weakness. If models is imperfect, if the models are imperfect, they have got limitations, then agents decision will also suffer because of the model limitations. Dependence on data quality. So basically, agents, they operate on inputs and not truth. So the idea is that when we train the model, like the large language model, whatever data we are supplying, the training data we are using, so model will learn based on that only. If the training data has got ambiguities, some imperfections, some ambiguities, some wrong informations, then model will learn that. So model cannot learn the truth, but it will learn whatever you will feed it, the training data you will provide. And hence agents operate on inputs and not the truth. So data issues include, so what can be the issues with the data? Incomplete information, outdated records, noisy inputs, conflicting sources. And because of these issues like incomplete information, outdated records, noisy inputs, conflicting resources, what consequences we might face? So agents, they will like have poor decision making, agents will show inconsistent behavior, and it will lead to reduce the trust. So good agents, they require reliable data pipelines, validation checks, and clear data prov- provenance. So this is like a very important point we discussed, that agents performance, they also depend on data quality. It depends on model quality as well as data quality. Now I have a question for you. So you can comment this. So you give me an example of data consequence in your field. So you can comment this. Handling unexpected scenarios. So the real world where we live in, or where the agents operate, it is highly unpredictable. So real world unpredictability and intelligent agents. So real world environments are unpredictable. So agents, they might encounter novel edge cases. Novel edge cases means the scenarios which the agents have never seen before, the scenarios which the agents have never trained on. So that those are the novel edge cases. So agents may encounter novel edge cases, ambiguous instructions, missing data, conflicting constraints. So all these agents may encounter, and these are the uncertainty or real world unpredictability, novel edge cases, ambiguous instructions, missing data, conflicting constraints. Now, when agents, they come across unpredictability, real world unpredictability, then what agents can do? So agents can attempt reasonable recovery, or they can ask clarifying questions. Like in case of ambiguous instructions, they can ask clarifying questions, they can attempt reasonable recovery. And if agents feel like they are not able to solve a problem, they should escalate to humans. So this is a good practice. So intelligent agents, since they operate in the real world, they have to deal with the real world unpredictability, and how they should behave is they should attempt reasonable recovery, they should ask clarifying questions, and they should escalate to humans when they are unable to solve problems or solve a problem. What agents cannot do? Invent correct answers reliably. Agents cannot invent correct answers. Whatever we have trained agents will give answer based on that training. Like let us suppose we are giving agents some novel edge case on which the agent has never trained before. Agent will never be able to answer that. So, so agents cannot invent correct answers reliably. Agents cannot handle every edge case flawlessly. So edge case is something, novel edge case is something where agents do fail because they cannot invent answers, correct answers reliably, and they cannot, hence they cannot handle every edge case flawlessly. And the way agents should act is they should attempt reasonable recovery, they should ask clarifying questions, and they should escalate to humans. So the design principle the agent should follow is, so the idea is that when we are designing AI agents or building apps with AI agents, the design principle we should keep in mind is failure modes must be anticipated, not ignored. So we should be well prepared that okay, agents can fail. So those failure modes we should anticipate and we should design our application taking into consideration those failure modes. We cannot ignore failure modes. We cannot over trust agents saying that they are something magical. We already saw agents do have limitations and we cannot over trust, over rely on them, and hence we should not ignore failure modes. Rather, we should uh, take it into consideration and we should anticipate it, failure modes. The need for human oversight. Now it's very important to have human in the loop. So it is essential and it's not optional, human in the loop. Because we already saw that agents, they are not as smart as humans. They do have limitations. They depend on the quality of the model, the quality of the data. They can make mistakes, they can hallucinate, they can do wrong reasoning, and hence human, the agents cannot replace humans. Human should be there in the loop. It's essential. So the idea is that no serious agent system operates without humans. Now, what is the role of humans? So let us suppose we have an AI agent. Now this AI agent, it is facing some uncertainty or real world unpredictability, some exception it is facing. Then that AI agent, it is not able to decide what to do. Then it will escalate the issue to the human. So that is the human in the loop. Then human will help agent in deciding what to do. So humans will guide, humans will provide guidance or some corrections, and AI agents will learn that and it will work. So the idea is that AI agent, it is smart. Most of the things it will do on its own, but when because AI agent, it is working in the real world environment, when it is exposed to some real world unpredictability, uncertainty, or exception, real world exception, in that scenario, this AI agent, it will not be able to handle that. Like some novel edge case which the agent has never seen before, the AI agent has never been trained on. That is something very new, the novel edge case. And the AI agent, it will get confused. It will start hallucinating. It will get stuck what to do. And whenever it gets stuck, the design principle, the best practice you should follow is we should escalate to humans, wherein humans will provide guidance and corrections. So with this, the human role is very clear. So humans, uh, like the approval checkpoints, exception handling, ethical judgment, and system supervision. So humans, so in the human in the loop. So what humans will be doing in the loop is they will be approving the checkpoints. They will be handling the exception when the AI agents is not able to do that. They'll play a role in ethical judgment and system supervision. So with this, one very important point we can say is human in the loop is not a weakness. It is a safety mechanism. So now it's very much clear to us that whenever we are building apps with AI agents, using AI agents, we have to have human in the loop because it's a safety mechanism. So the goal is replace busy work, not accountability. So the idea is that we should make use of AI agents to replace some busy work, but not to replace accountability. For accountability, humans should be there in the loop. Continuous monitoring requirements. Now, see, if I talk about agents, they are living systems, not static deployment. Meaning to say that AI agents, they keep on working in the background asynchronously. They are working to achieve goal. They are cooking the strategy. They are executing the action plan. They are reflecting on the outcomes. They are adapting. They are revising the plan. They are re-strategizing. They are doing all this till the goal is achieved. Hence, agents are living systems. They are not static deployment that, okay, we deployed it and we are done. It is evolving. Agents, they are continuously, they are adapting. Agents are highly adaptable. So if I talk about AI agents, they require performance monitoring. Now, this is very important. See, agents, since they are solving the problem on their own and not just solving the problem, rather they are acting on their own, performing actions on the behalf of the user. They are executing the strategies on the behalf of the user. There is a need to monitor the performance of the agents. What if agents, they are drifting away from the goal? So we performance monitoring. So agents, although they are autonomous, they act independently, they act freely, but still they require performance monitoring. They require drift detection, wherein we should ensure that the agent, it is not drifting away from the goal. AI agents require error tracking, and they also want feedback analysis. So now it's very much clear to us that AI agents, they are not magical. They have got some limitations associated with them. And because of that, AI agents, they require performance monitoring, they require drift detection, they require error tracking, and they require feedback analysis. And why is it so? Why they require all this? The reason for that is agents, they live in a real world wherein models, they evolve, because new, like, the context is getting added, and that context is giving, like, adding new intelligence to the model on top of the model. And hence agents, they are adapting with the real world scenarios. So models evolve, data changes, user behavior shifts. This is something very interesting, very important. Now see, the idea is that, like, let us suppose we made a agentic AI application. After 6 months, the data which we trained on might not be that much relevant, because after 6 months, some very big policy changes might have happened, and hence the model might be needing new intelligence. So if we don't supervise the model, if we don't track the performance or error or drift detection or feedback analysis, then models, or if we overtrust the models, then models will keep on making mistakes and will just keep on ignoring it. So the idea is that whatever agentic AI applications we are making, it needs continuous maintenance. The reason for that is the intelligence is also evolving. So whatever the context we have provided, or the data we have provided for training, after a period of time, it might not be relevant at all. Even the user behavior shifts. And the best example, one of the very good example of this is COVID-19. Just imagine, before COVID-19, the world was very different. And just after COVID-19, the world was very different. And because it was a global pandemic, and we saw something like lockdowns. In so many countries, we saw lockdowns. So it was a total reset. So definitely a model after COVID-19, post COVID-19, the trends it will be watching will be very much different. So the data it was trained before COVID-19 and after COVID-19, data has changed significantly. So if we don't look into the performance of the model, or if we don't detect the drift, error, if we don't analyze the feedbacks, then the model will keep on making mistakes. So the idea is that without monitoring, agents, they silently degrade. So this is very important. So now it's very important that whenever we are building agentic AI applications, continuous monitoring is something very important. So failure is often invisible until it's too late. So continuous monitoring is required. Ethical and operational risk. Now agents, they introduce new risk which we have never seen before. So we have something called as ethical risk associated with agentic AI applications, like uh, bias amplification. Like if there is some biasness is there in the data or the context or the prompt, then that will only amplify, and that will like very badly affect the decisions of the AI agents. So bias amplification is a very big ethical risk associated with AI agents. Privacy violations. Now AI agents, they might violate the privacy. Unintended harm, because see agents, they might perform some actions which might be very harmful for the humans or dangerous. So uh, AI agents, they might show unintended behavior. If proper guardrails, if proper safety rules are not in the place, then AI agents, they might drift away from the goal. And if they drift away from the goal, they start showing some unintended behavior, and they can cause harm also. So that is the unintended harm we are talking about. And one more very important ethical risk associated with AI agents is the lack of transparency, because AI agents, they are acting like a black box. We don't know what's happening in the background, and that's the lack of transparency. And if we talk about operational risk associated with AI agents, so we have automation errors at scale. So let us suppose AI agent, it made a small mistake, and in automation it will have a cascading effect, wherein, because in automation it's like step 1, step 2, step 3, it's like a chain. Now if a error is there in step 2, it will get migrated. So it will be a cascading effect. So automation errors at scale, and it will lead to cascading failures. Over reliance on AI is a operational risk, because let us suppose a company or a industry, it relied on AI so much that it replaced all its human workforce. It fired all its human workforce. And what if AI start giving wrong answers? It starts hallucinating. What if then? So that is the over reliance on AI. So that is a operational risk. And regulatory exposure. So these are like operational risk associated with AI agents. So the mitigation requires. So the idea is that now this is a very important discussion we are making. So whenever we are designing agentic AI applications, we have to set clear boundaries. We have to audit trials. We have to look into the policy enforcement, and we have to implement governance structures. So these are like very very important, because so if we consider all this, like clear boundaries, audit trials, policy enforcement, governance structures, we are basically implementing guardrails, safety rules, and hence we are mitigating the ethical risk as well as the operational risk, avoiding over automation. Now see, the idea is that over automation, it might lead to loss of human judgment, because if over automation means we are eliminating humans to a very large extent, human in the loop, we are basically missing that. So over automation, it will lead to loss of human judgment, because humans will not be in the picture. AI will be taking care of the entire automation. So human touch will be missing, and that can be dangerous. Reduced situational awareness and poor edge case handling. Since humans will not be there in the loop, uh, any edge case and the AI will fail. It will hallucinate. Even the situational awareness, because if humans are there in the loop, they are aware of the situations. Humans have got some good situational awareness, and they can incorporate it if they are in the loop. But if we do over automation, we are eliminating humans to a very large extent. And because of that, loss of human judgment, reduced situational awareness, and poor edge case handling is what we will get. So the idea is that just because an agent can automate something does not mean it should. So the idea is that just because AI agents can automate, it does not mean that we should over automate. A balance should be maintained. Because see, if I talk about AI agents, they deal with two types of decisions: high risk decisions, which are irreversible in nature. Like, high risk decisions are decisions related to life, death, major financial. So the idea is that whenever there is a need to decide on a high risk or take a high risk decision, a irreversible decision, do not automate. It will require human review. And if a reversible or low risk decision is involved, like scheduling, data entry, then we can consider automation, and we can consider to monitor the outcomes. So now we are discussing like how to avoid over automation. So the best way to avoid over automation is to first identify the type of the decision, whether it's a high risk irreversible decision or a low risk reversible decision. If it's a high risk decision which is irreversible in nature, which concerns decisions like life or death, major financial losses, we should not automate. Rather, we should bring human into the picture. And for low risk reversible decisions, we can consider automation, and we should monitor the outcomes. So in this way, we can avoid over automation. Aligning stakeholder expectations. Now we have different stakeholders, and different stakeholders will have different expectations. For example, if I talk about engineers, their expectation will be they will be wanting reliability. Regulators, they will be wanting compliance. Users, they will be looking for trust. They will be wanting trust. And executives, they will be wanting return on investment. So different stakeholders will be having different expectations. And if there is a misalignment in the expectations, it will lead to project failure, loss of credibility, organizational resistance. So alignment with stakeholder expectation is very, very important. So alignment requires clear communication, transparent limitations, gradual rollout, measurable success criteria. So the idea is that in any project you will be building, different stakeholders will be involved, and before like implementing or writing even a single line of code, first we should be very clear. Like, we should have meetings with the different stakeholders, and clear communication is the key. So we should have clear communication so that a transparency is there, and transparent limitations. We should not overcommit. Transparent limitations is something very important. Gradual rollout. We should like in an agile way, gradual rollout, and measurable success criteria we should set so that everybody is on the same page. Engineers will have a different success criteria related to reliability. Regulators will have different success criteria related to compliance. Users will have different success criteria based on the trust, and executives will have different success criteria based on the return on investment. So in this way, everybody will be on the same page. Common expectation traps. So if we talk about incorrect framing, so if we say that the agent will handle everything, it's an incorrect framing. And here we are over trusting, or there is a over reliance on AI agents. It will always be correct. It's a wrong, incorrect framing. We should not do that. We don't need humans anymore. So we already saw that humans in the loop is essential. It's very important. We can deploy and forget. So this is also very important. Like, agents, they are live. It's not like static deployment, right? Because agents, we have to keep on evolving it, because the data nature of the data is changing, user behavior is changing, models, they need to be updated with the new intelligence. So we cannot deploy and forget. So the correct framing would be when building AI applications or the agentic AI applications, the assist. Agent assist means human will be there in the loop, and agents will just help humans. Agents will assist humans. The agent escalates when uncertain. The agent improves with oversight. So agent is not something perfect, something magical. It also keep on improving. It needs human in the loop, and it might hallucinate when dealing with novel edge cases, and there it should escalate to humans. So now, and this is answering the expectations, managing expectations from AI agents, designing for trust, not capability. So basically, whenever we are building AI, agentic AI applications, we have to design for trust and not for capability and features, because trust is very important. Users want trust, and users. So the idea is that so trust is earned through predictable behavior, consistent and reliable. So if the agentic AI applications, it is giving correct answers, it is behaving like consistently and reliably, then users will start having trust on that agentic AI application. Trust is earned through clear boundaries, that is, a defined limitations. Honest uncertainty communicates confidence level. So this is very, very important. Like, let us suppose an agentic AI application is there. It is handling a novel edge case, and due to some reason, it is not able to escalate that to the human. Now, agent have to come up with an answer for that novel edge case. So it should be very much honest. So definitely it is not at all sure about the answer or the response or the reasoning it will be doing for that novel edge case. So it should be very honest to say that review might be needed, or it should honestly express itself that okay, whatever advice I am giving or whatever the output is, uh, it is like low confidence level, like that something should be there. And trust is earned through explainable actions. So reasoning should be transparent. So whatever the reasoning the AI agent is doing, it should be transparent. Then trust is earned. So the idea is the AI agents, they should admit uncertainty. So whenever they are unsure or low confidence, they should admit it. Agents should ask for help, like human in the loop, the clarify instructions. Agents should log decisions. This is very important, logging the decisions. Yeah. So they should record choices and context for review. And agents should support auditability, like traceable and verifiable operations. So finally, we completed this lecture. So in this lecture, we saw that agents are not magical. They are powerful, but they have got limitations. Agents cannot replace humans completely. Humans should be there in the loop. So we got a very good understanding that why we should be managing expectations from AI agents, why overhype can be dangerous. We also saw where agents might fail, and hence the importance of oversight, human oversight. And we also looked into some best practices of how to deploy agents responsibly. So that is something called as responsible AI. So we looked into some very interesting principles of responsible AI, wherein one very important point to you should always remember is that whenever a high risk decision is involved, which is irreversible in nature, try not to automate it. Rather, human review should be there for that high risk decision. And for low risk reversible decisions, definitely we should automate those tasks, and we should monitor the outcomes. So I hope you got a very good understanding of the concepts which we discussed in this lecture. So do subscribe to our YouTube channel, Scale Up University, for more such interesting lectures and courses. Thanks for watching. Thanks for your time.